Picture this. It's 1450 and you're standing in the middle of what looks like complete chaos. Water wheels are pounding away like giant wooden hammers. Steam is rising from mysterious vats that smell worse than your worst nightmare. And everywhere you look, people are pulling, stretching, beating, and dunking what used to be perfectly innocent sheep fleece. Welcome to medieval Europe's economic powerhouse, the cloth mill. This isn't just some quaint historical curiosity we're talking about here. This single industry paid for cathedrals, funded entire armies, and turned sleepy farming villages into bustling trade centres that could make or break kingdoms. You want to know what really drove medieval Europe's economy? Forget gold, forget spices, it was sheep. More specifically, it was what happened to those sheep after they got their annual haircuts. A single piece of broadcloth represented months of work from dozens of specialists, each one adding their particular brand of medieval magic to transform raw wool into something so valuable that merchants would risk their lives crossing bandit-infested roads just to get their hands on it. We're talking about an industry that employed more people than farming in some regions and generated more wealth than most kings ever dreamed of seeing. The numbers tell an incredible story. By the 1300s, England alone was producing over 40,000 sacks of wool annually. That's roughly £8 million of the stuff. But here's where it gets really interesting. Exporting raw wool was like throwing money away. The real profit came from turning that wool into finished cloth. And that's where our story begins. A raw fleece might sell for a few pence, but that same fleece, once it went through the full cloth-making process, could be worth 20 times as much. Talk about adding value. Today we're following one specific piece of wool through the entire medieval cloth-making process. From the moment it comes off a sheep's back to when it gets stamped with a town seal and shipped off to make someone very wealthy. Trust me, by the time we're done, you'll never look at your wool sweater the same way again. This wasn't just manufacturing, it was medieval alchemy, turning animal hair into Europe's most precious export. The whole process started with what might be the most traumatic haircut in history. Sheep shearing in the 1400s was an art form that would make modern stylists weep. These weren't your friendly neighbourhood sheep either. Medieval sheep were smaller, scruffier, and produced fleece that looked more like dreadlocks than the fluffy clouds we see today. The average sheep yielded about 2 pounds of wool, but not all wool was created equal. Smart shearers knew exactly where to cut, because the wool from a sheep's sides was worth twice as much as the stuff from its belly. Shearing day was basically the Super Bowl of the medieval agricultural calendar. Entire communities would gather to help because timing was everything. Too early and the wool was too short. Too late, and you'd lose quality as the fleece started to felt naturally from the sheep's own movement and weather. The tools were simple but deadly effective. Iron shears that looked more like torture devices than grooming equipment. One wrong move could leave you with a very unhappy sheep and significantly less wool than you started with. But here's where the real skill came in, sorting the fleece immediately after shearing. This wasn't a job for amateurs. Expert sorters could tell the quality of wool just by running their fingers through it, separating the long, strong fibres from the short, weak ones. The finest wool came from the sheep's shoulders and sides. This stuff was destined for luxury cloth that only the wealthy could afford. The coarser wool from the legs and belly would become everyday fabric for common folks. Even the absolute worst bits weren't wasted. They'd get turned into rope or padding. The sorting process was like medieval quality control on steroids. Sorters had specific names for different grades of wool: fine, good, middle, and breech. And mixing them up was the kind of mistake that could ruin your reputation permanently. A master sorter could process an entire fleece in minutes, their hands moving faster than card dealers, separating wool into precise categories that would determine its final destination and price. Once the wool was sorted, the real fun began with something called scouring. If you think your laundry is a chore, try washing sheep fleece the medieval way. Raw wool was absolutely disgusting, covered in lanolin, dirt, plant matter, and things we probably don't want to think too hard about. The lanolin was the biggest problem. It's a natural oil that protects sheep from water, which means it also protects wool from getting clean. Removing it required some pretty creative chemistry. Medieval wool workers discovered that the best cleaning agent was something they had plenty of: urine. Yes, you heard that right. Human urine, when aged for a few weeks, produces ammonia, one of the most effective degreasers nature ever invented. Workers would collect urine in large vats and let it ferment until it reached the perfect strength for cutting through lanolin. The smell was apparently so memorable that cloth towns could be identified from miles away just by following your nose. The scouring process itself was like a medieval washing machine operated by human power. Workers would dump the fleece into large wooden tubs filled with warm water and aged urine, then stomp on it for hours. This wasn't gentle treatment. They'd beat the wool with wooden paddles, wring it out, rinse it in fresh water, and repeat the process until the water finally ran clear. A single fleece might go through this cycle 5 or 6 times before it was considered clean enough for the next step. Some operations used alternatives to urine, lye made from wood ash or imported soap for the highest quality wool. But urine remained the standard because it was free, effective, and always available. Workers developed techniques for testing the strength of their cleaning solutions, looking for that perfect balance between removing the lanolin and not damaging the wool fibers themselves. Too weak, and the wool stayed greasy; too strong, and you'd end up with something that looked more like cotton candy than sheep fleece. The cleaned wool still wasn't ready for spinning. First, it needed to be prepared through a process called carding or combing, depending on the final product they were aiming for. This is where medieval textile workers really showed their expertise, because getting this step wrong would mess up everything that came after. Carding was done with wooden paddles covered in bent wire teeth. Imagine oversized dog brushes designed by someone with a medieval torture fetish. Workers would take small handfuls of clean wool and brush it between 2 cards, pulling the fibers in opposite directions until they all lined up parallel. The motion looked simple, but it required serious skill to avoid breaking the fibers or creating weak spots that would show up later in the finished cloth. The rhythm of carding was hypnotic: brush, flip, brush, flip, brush, flip, sometimes for 8 hours straight. Experienced carders could process several pounds of wool per day, their hands moving in practiced patterns while they chatted with other workers or sang traditional work songs. The wool gradually transformed from tangled mess to neat, fluffy rolags ready for spinning. The quality of the carding directly affected the strength and appearance of the final cloth, so master carders were highly valued and well-paid members of the textile team. Combing was reserved for the finest wools destined to become luxury fabrics. Instead of cards, combers used metal combs with long, sharp teeth set into heated wooden handles. They'd load wool onto one comb, then use the second comb to pull the fibers straight, while removing any remaining short or broken pieces. This process was slower than carding, but produced perfectly aligned fibers that would spin into incredibly strong, smooth thread. The combed wool came off looking like silk, long, lustrous, and ready to become the kind of thread that wealthy merchants would pay premium prices for. Master combers guarded their techniques jealously because the difference between good combing and great combing could mean the difference between ordinary cloth and fabric fit for royalty. Now came the part that really separated the professionals from the amateurs. Spinning. This wasn't your grandmother's spinning wheel either. We're talking about technology that was revolutionary for its time. The spinning process turned those carefully prepared wool fibers into continuous threads strong enough to weave into cloth. The basic principle was simple: twist the fibers together while gradually drawing them out into a thin, even strand. The execution, however, required years of practice to master. Most spinning in the early medieval period was done with a distaff and spindle, tools that looked deceptively simple but demanded incredible skill to use effectively. The distaff held the prepared wool, while the spindle did the actual spinning. Spinners would pinch a few fibers between their fingers, give the spindle a twist, and slowly draw out the forming thread while maintaining just the right amount of tension. Too little tension, and the thread would be weak and lumpy. Too much, and it would break constantly. The introduction of the great wheel around 1400 revolutionized spinning productivity. This wasn't just an improvement, it was like upgrading from a bicycle to a motorcycle. The great wheel allowed spinners to produce thread much faster while maintaining consistent quality. The wheel would spin continuously while the operator walked back and forth, drawing out the thread to the perfect thickness before winding it onto the spindle. Master spinners could produce thread so fine and even that it looked almost machine-made. They developed techniques for controlling the twist rate, managing fiber tension, and creating different thread weights for different purposes. Warp threads needed to be stronger than weft threads, so they got more twist. Luxury fabrics required finer thread, which meant drawing out fewer fibers over longer distances. Each type of cloth demanded its own specific thread characteristics, and experienced spinners knew exactly how to produce what the weavers needed. The spinning process also revealed the true quality of the earlier preparation work. Poorly sorted wool would create weak spots in the thread. Inadequate scouring would leave greasy patches that wouldn't take dye properly. Bad carding would result in lumpy, uneven thread that would show up as flaws in the finished fabric. This is why every step in the process required genuine expertise. One weak link would ruin months of work and thousands of pounds of valuable wool. Thread production was measured in hanks and skeins, with specific standards for length and weight that varied by region and intended use. A skilled spinner could produce several miles of thread per day, but the finest threads took much longer because they required more careful handling and attention to detail. The economic impact was enormous. By some estimates, spinning employed more people than any other single occupation in medieval cloth towns, with women doing most of the work as part of the putting out system that distributed textile production across entire regions. But all this spinning was just preparation for the main event, turning those countless miles of thread into actual cloth through the ancient art of weaving. The weaving process was where medieval textile production really showed off its technical sophistication. We're talking about technology that would make modern engineers nod with respect. Massive wooden looms that stood 8 feet tall and stretched 12 feet wide, capable of producing cloth so consistent you'd swear it came from a factory. The broadloom wasn't just a tool, it was a precision instrument that required years of training to operate properly. Setting up a broadloom was like tuning a giant wooden piano with hundreds of strings. The warp threads, those running lengthwise, had to be measured, sized, and threaded through heddles with mathematical precision. A single piece of broadcloth might contain over 3,000 individual warp threads, each one tensioned to exactly the right tightness. Too loose, and the cloth would be uneven. Too tight, and threads would snap under the constant stress of weaving. Master weavers could tell if a thread was properly tensioned just by plucking it and listening to the sound it made. The sizing process alone was an art form that would make modern chemists jealous. Warp threads needed to be coated with a mixture of flour paste, egg whites, and sometimes beer to make them strong enough to withstand thousands of passes through the loom. This sizing had to be applied evenly. Too much, and the threads would stick together. Too little, and they'd break constantly during weaving. Some weavers developed their own secret sizing recipes, passing them down through generations like family treasures. Guild regulations controlled everything about the weaving process, down to the exact width a piece of broadcloth could be. Standard broadcloth measured exactly 63 inches wide, not 62, not 64, but precisely 63 inches. Cloth that didn't meet these specifications would be rejected by the drapers and couldn't be sold in major markets. Weavers used special measuring devices and regularly checked their work to ensure perfect consistency. Getting caught selling short measure cloth could result in fines, public humiliation, or even banishment from the guild. The actual weaving was a full-body workout that would put modern gym routines to shame. Weavers worked the treadles with their feet to raise and lower different sets of warp threads, through the shuttle containing the weft thread back and forth with practiced precision, and beat each row into place with a heavy wooden beater. A skilled weaver could complete about 2 inches of broadcloth per day. That might not sound like much, but when you consider they were working with thousands of threads and had to maintain perfect consistency, it was actually remarkable productivity. The shuttle work was where you could really tell an expert from an amateur. Master weavers could throw that shuttle across 12 feet of loom and catch it on the other side without missing a beat, maintaining a rhythm so steady you could set your watch by it. The weft thread had to be kept at exactly the right tension. Pull too hard, and the cloth would pucker; too loose, and it would be weak and uneven. Some weavers developed calluses on their catching hand from years of shuttle work, wearing them like badges of honor. Different patterns required different techniques, and the most complex designs pushed both the loom technology and weaver skill to their limits. Simple tabby weave went over one, under one in a basic checkerboard pattern. Twill weave created diagonal patterns by shifting the over-under sequence with each row. The fanciest broadcloth featured complex patterns that required hundreds of heddles and took months to complete. These luxury fabrics commanded prices that would make your eyes water. A single yard of the finest patterned broadcloth could cost more than a craftsman's annual wages. But even the most perfectly woven cloth wasn't ready for market yet. Straight off the loom, broadcloth was loose, thin, and frankly not very impressive. It needed to go through a transformation process that would turn this ordinary-looking fabric into the dense, luxurious material that made medieval cloth famous throughout Europe. This transformation happened at the fulling mill, and it was here that medieval technology really showed its genius. The journey to the fulling mill was like taking your cloth to the medieval equivalent of a high-tech factory. These mills were marvels of engineering that harnessed water power to do work that would otherwise require dozens of men. The sound hit you first, a rhythmic pounding that could be heard for miles, like giant wooden hearts beating in perfect synchronization. Mill owners chose their locations carefully, building where rivers provided consistent water flow year-round. A mill that ran dry during summer drought was worthless. Inside the mill, the technology was surprisingly sophisticated. The water wheel turned a wooden shaft fitted with cams, basically wooden bumps, that lifted and dropped massive wooden hammers called fulling stocks. These hammers weighed hundreds of pounds each and fell with enough force to compress and mat the wool fibers together. The rhythm was hypnotic. Lift, drop, pound, lift, drop, pound, hour after hour, day after day. The cloth went into wooden troughs filled with warm water and fuller's earth, a special clay that helped the felting process. Fuller's earth was so valuable that mills guarded their sources jealously, and some types were traded across international borders like precious commodities. The best fuller's earth came from specific quarries and had different properties depending on its mineral content. Master fullers could tell the quality of fuller's earth just by feeling it between their fingers. The pounding process gradually transformed the loose weave into dense, waterproof fabric. The mechanical action forced the wool fibers to lock together in a process called felting, while the fuller's earth helped remove any remaining grease and impurities. A piece of cloth might spend anywhere from 6 hours to 3 days under the hammers, depending on the desired final thickness and quality. The mill workers had to monitor the process constantly, checking the fabric's progress and adjusting the treatment as needed. Water-powered fulling was revolutionary because it could do in hours what foot fulling took days to accomplish. Before mills, fulling was done by workers who literally stomped on wet cloth in wooden tubs, back-breaking labour that produced inconsistent results. The mills not only worked faster, but created much more uniform fabric. A single mill could process enough cloth to supply an entire region, transforming local economies and making high-quality broadcloth affordable for more people. The economics of fulling mills were staggering. A well-located mill could process hundreds of pieces of cloth per month, charging fees that made mill owners some of the wealthiest people in medieval towns. Some mills became so profitable that nobles fought wars over water rights, and mill ownership was passed down through generations like royal titles. The combination of consistent water power and skilled operators made these mills the backbone of the medieval cloth industry. But the pounding was just the beginning of the finishing process. Once the cloth emerged from the fulling mill, damp and dense but still rough around the edges, it needed to be stretched, dried, and shaped into its final form. This is where we get the expression on tenterhooks. And trust me, medieval cloth workers knew exactly what that anxiety felt like. Tenter frames were massive wooden structures that stretched across hillsides like medieval laundry lines on steroids. These frames could be hundreds of feet long and held dozens of pieces of cloth simultaneously. The cloth was attached to the frame using tenterhooks, sharp metal hooks that gripped the fabric edges and held it taut while it dried. Getting the tension exactly right was crucial because this was the last chance to ensure the cloth met the required width and length standards. The stretching process was like performing surgery on fabric. Workers had to pull the cloth to precise dimensions while it was still damp and pliable, then secure it with tenterhooks spaced at exact intervals. Too much tension would thin the fabric and create weak spots. Too little would result in cloth that didn't meet guild specifications. Master tenters developed techniques for reading the fabric's response to stretching, knowing exactly how much force to apply and where to place each hook for optimal results. Weather was the wild card in the drying process. Perfect drying conditions required warm, breezy days with low humidity. Basically, medieval cloth workers were at the mercy of meteorology. Rain could ruin weeks of work in minutes, turning valuable broadcloth into expensive rags. Some operations built covered tenter frames, but most had to gamble on the weather and hope for the best. Night watchmen guarded the drying cloth not just from thieves, but from sudden weather changes that could destroy entire batches. Theft was a constant concern because cloth on the tenter frames was incredibly vulnerable. A single piece of high-quality broadcloth represented months of wages for most workers, making it an irresistible target for criminals. Towns hired special constables to patrol the tenter grounds, and some operations used guard dogs to deter nighttime raids. Getting caught stealing cloth from tenter frames was a serious crime that could result in prison time or even execution, depending on the value of the stolen goods. The timing of the tentering process was absolutely critical. Cloth had to be stretched while still damp from fulling but not soaking wet. Too wet, and the tenter hooks would tear right through the fabric. Too dry, and the cloth wouldn't stretch properly. Experienced tenters could judge the perfect moisture level just by touching the cloth, knowing exactly when it was ready for the frames. Some operations kept the cloth damp by sprinkling it with water throughout the stretching process, but this required constant attention and perfect timing. The tenter frames themselves were engineering marvels that would impress modern construction workers. These weren't flimsy wooden structures. They were built to withstand tremendous forces as dozens of pieces of wet cloth pulled against them in different directions. The frames had to be perfectly level and straight, or the cloth would dry unevenly and fail quality inspections. Master carpenters specialized in building tenter frames, and their reputation could make or break a cloth operation's success. But even perfectly stretched and dried cloth wasn't ready for market yet. The surface was still rough and uneven, covered with loose fibers that stuck out in all directions. This is where the medieval finishing process really showed its artistry, transforming rough broadcloth into fabric so smooth and lustrous it looked almost magical. The raising process was where cloth workers literally made the fabric stand up and pay attention. Using tools called teasels, dried flower heads covered in tiny hooks, workers would brush the cloth surface to pull up loose fibers and create a soft, fuzzy texture called nap. Teasels were perfect for this job because their hooks were just the right size and flexibility to lift fibers without damaging the underlying weave. These natural tools were so effective that textile workers continued using them for centuries, even after metal alternatives became available. The technique looked simple, but required incredible skill and patience. Workers would drag teasels across the cloth surface in long, smooth strokes, gradually building up the nap to create a uniform texture. Too much pressure would damage the fabric. Too little wouldn't raise enough fibers. The direction of the strokes mattered too. Master raisers knew exactly which way to brush different types of cloth to achieve the desired effect. Some luxury fabrics went through the raising process multiple times to create an incredibly deep, soft nap that felt like velvet. Quality control during raising was intense because mistakes at this stage could ruin months of previous work. Supervisors would inspect every inch of raised cloth, looking for thin spots, tears, or uneven nap that would lower its value. Workers who consistently produced substandard work would find themselves looking for new employment pretty quickly. The economic pressure was enormous because a single damaged piece of broadcloth could represent several pounds of lost profit. After raising came shearing, and this is where medieval textile workers really earned their reputation as craftsmen. Using massive shears that looked more like hedge trimmers than scissors, skilled workers would carefully trim the raised nap to create a perfectly smooth, even surface. These shears were works of art in themselves. Some were over 2 feet long and weighed several pounds, requiring both hands to operate effectively. The shearing technique was like giving the cloth the world's most expensive haircut. Workers had to maintain consistent pressure and cutting angle across the entire fabric surface, removing just enough nap to create smoothness without cutting into the underlying weave. Master shearmen could work for hours without creating a single uneven spot, their hands moving in practice patterns while they maintained perfect concentration. One slip of the shears could create a thin spot that would show up in the finished garment and destroy the cloth's value. The finest broadcloth went through multiple rounds of raising and shearing, with each cycle creating a smoother, more lustrous surface. Luxury fabrics might be raised and sheared 5 or 6 times, with master craftsmen working on each stage. This repeated process was incredibly labor-intensive and expensive, but it created cloth so fine it competed with silk imports from Asia. The difference between ordinary broadcloth and premium fabric was literally visible. Premium cloth had a mirror-like surface that reflected light like water. Tool maintenance was crucial for both raising and shearing operations. Teasels had to be replaced regularly as their hooks wore down or broke. The finest teasels came from specific regions and were graded by quality, just like the wool itself. Shears required constant sharpening and adjustment to maintain their cutting edge. Some shearmen owned sets of shears worth more than most people's annual income, and they guarded these tools like precious family heirlooms. But even the most perfectly finished cloth meant nothing if it was the wrong color. Medieval people were absolutely obsessed with color. Not just any color, but specific shades that indicated status, wealth, and social position. This is where the dye house entered our story, and trust me, medieval dyeing was part chemistry lab, part artistic studio, and part medieval torture chamber, all rolled into one steamy, stinking operation. The dye house was easily the most mysterious and dangerous part of the entire cloth-making process. These weren't just buildings where people mixed colors. They were laboratories where master dyers performed what looked like alchemy, transforming plain white cloth into brilliant reds, deep blues, and rich purples that would make modern chemists jealous. The smell alone could knock you off your feet from 100 yards away, a combination of boiling plant matter, fermented urine, and chemical reactions that probably violated several laws of nature. Different colors required completely different processes and ingredients, some of which were more valuable than gold. Woad, the primary source of blue dye, had to be fermented for months in massive vats that bubbled and stank like medieval science experiments. The fermentation process was so complex that master dyers kept their techniques secret, passing them down through generations like magical formulas. Getting the fermentation wrong would ruin entire batches of expensive dye and could bankrupt a dye house operation. Red dyes were even more complicated and expensive. The finest reds came from kermes, tiny insects that lived on Mediterranean oak trees. These insects had to be collected at exactly the right time of year, dried properly, and ground into powder that cost more per pound than silver. Madder root provided a cheaper red alternative, but it required different mordants and processing techniques to achieve acceptable colour fastness. Master dyers could tell the quality of red dye ingredients just by their smell and colour. The mordanting process was where medieval chemistry really showed its sophistication. Mordants were chemicals that helped dyes bond permanently with wool fibres, preventing colours from washing out or fading quickly. Alum was the most common mordant, imported at great expense from specialised mines in Asia Minor. The mordanting process had to be done at precise temperatures, with exact concentrations. Too little mordant, and the colours would fade. Too much, and the wool would become brittle and weak. Temperature control in medieval dye houses was an art form that would challenge modern industrial operations. Different dyes required different heat levels, and maintaining consistent temperatures without modern thermometers required incredible skill and experience. Master dyers could judge water temperature by sight, sound, and steam patterns, knowing exactly when conditions were perfect for each stage of the dyeing process. Some operations used elaborate systems of pipes and channels to control water flow and temperature throughout the dye house. The actual dyeing process was like conducting a chemical orchestra where every ingredient had to enter at exactly the right moment. Cloth would be soaked in mordant baths, rinsed in specific sequences, then immersed in dye vats that had been brewing for days or weeks. The timing was critical. Leave cloth in the dye too long, and it would become oversaturated and muddy. Remove it too early, and the colour would be weak and patchy. Master dyers developed techniques for reading the cloth's response to different treatments, knowing exactly when to move to the next stage. Quality control in dyeing was ruthless because colour mistakes were impossible to hide. Cloth that didn't meet colour standards would be rejected by drapers and merchants, representing complete financial loss for everyone involved in its production. Some dye houses employed colour masters, whose only job was inspecting finished cloth under different lighting conditions to ensure consistency and quality. These experts could spot colour variations invisible to untrained eyes and had the authority to reject entire batches of expensive cloth. The economics of dyeing were staggering. High-quality dyes could cost more than the cloth itself, and the most expensive colours were reserved for the wealthy elite who could afford such luxury. Purple dyes were so costly that owning purple cloth was literally a sign of royalty, not just metaphorically, but legally. Some colours were restricted by law to certain social classes, making the dye house a place where economics, chemistry, and politics all mixed together in those bubbling vats. But creating perfectly coloured cloth was only valuable if customers could trust they were getting what they paid for. This is where the inspection and sealing process entered the picture, and medieval quality control made modern manufacturing standards look casual by comparison. The draper's hall was where medieval cloth faced its final judgment. And trust me, these inspectors made modern quality control specialists look like they were just going through the motions. Every single piece of broadcloth had to pass through this gauntlet of measurement, examination, and testing before it could legally be sold. We're talking about inspectors who could spot a thread count discrepancy from across the room and had the authority to destroy months of work with a single red mark. The measuring process alone was a mathematical nightmare that would give accountants cold sweats. Standard broadcloth had to measure exactly 24 yards in length and 63 inches in width. Not approximately, not close enough, but precisely those dimensions. Inspectors used specially calibrated measuring rods that were checked against master standards kept under lock and key. A piece of cloth that measured even half an inch short would be rejected, fined, and marked as defective. Some towns kept their measuring standards in the cathedral, treating them like holy relics because economic prosperity literally depended on their accuracy. The inspection process was like a medieval CSI investigation, performed on fabric. Inspectors would unroll entire pieces of cloth, examining every inch for flaws, thin spots, color variations, or weaving errors. They looked for telltale signs of corner cutting. Threads that were too thin, dye that wasn't color fast, or fulling that hadn't been done properly. Master inspectors developed techniques for spotting problems that wouldn't be obvious to casual observers, but would show up later when the cloth was cut and sewn into garments. Quality marks were stamped directly onto the cloth using metal seals heated in charcoal fires. Each town had its own distinctive seal design, and getting caught counterfeiting these marks was a crime that could result in losing your hand. Literally. The sealing process was done with great ceremony because it represented the town's reputation and economic future. A cloth seal was essentially a medieval warranty that guaranteed the fabric met specific standards for materials, workmanship, and dimensions. The fining system was brutal in its precision. Cloth that failed inspection didn't just get rejected, it got penalized. Weavers whose cloth measured short would be fined amounts that could wipe out weeks of profit. Repeat offenders faced escalating punishments, including public humiliation, guild suspension, or permanent banishment from the trade. The economic pressure was so intense that some weavers would deliberately make their cloth slightly oversize rather than risk coming up short during inspection. Different grades of cloth received different types of seals, creating a complex hierarchy of quality marks that merchants and customers understood perfectly. The finest broadcloth received lead seals that were attached with special techniques to prevent counterfeiting. Ordinary cloth got simpler marks, while defective cloth was branded with seals that warned buyers about its limitations. This marking system created a medieval version of brand recognition where customers could identify quality cloth just by looking at its seals. The inspection halls themselves were architectural marvels designed specifically for cloth examination. These buildings featured massive windows positioned to provide perfect natural lighting, wooden floors marked with measurement lines, and specialized equipment for testing everything from thread strength to color fastness. Some halls employed dozens of inspectors during busy seasons, creating assembly lines of quality control that processed hundreds of pieces of cloth per day. But passing inspection was just the beginning of the final journey. Now the sealed, certified broadcloth needed to be packaged and shipped to markets across Europe. And this process turned medieval merchants into logistics experts who would impress modern supply chain managers. Packing broadcloth for long-distance transport was an art form that balanced protection, weight, and space efficiency. The cloth was carefully folded into standardized bundles called bales, with each fold positioned to prevent creasing that would lower the fabric's value. These bales were then wrapped in waterproof covers made from specially treated leather or canvas, creating packages that could survive months of rough handling during transport. Some merchants developed secret packing techniques that allowed them to fit more cloth into standard shipping containers, gaining competitive advantages in transportation costs. Lead cloth seals were attached to each bale as final proof of authenticity and quality. These seals were works of art in themselves, featuring intricate designs that were impossible to counterfeit with medieval technology. The sealing process involved melting lead in portable furnaces and stamping it while hot, creating permanent marks that would survive the rigors of international shipping. Merchants guarded their seal-making tools as carefully as they protected their gold, because counterfeit seals could destroy their reputations and ruin their businesses permanently. The transportation routes were like medieval superhighways that connected cloth-producing towns with markets across the known world. Flemish cloth travelled to Italian banking centres, English broadcloth found buyers in German trading posts, and specialty fabrics from small towns reached customers as far away as Constantinople. These trade routes required complex networks of agreements, payments, and protections that made medieval commerce far more sophisticated than most people realize. Credit systems developed around cloth trading were revolutionary for their time. Merchants couldn't carry enough gold and silver to pay for large cloth purchases, so they developed letters of credit that functioned like medieval checks. These financial instruments allowed cloth to be purchased in one country and paid for in another, creating an international banking system that rivaled anything in the modern world. Some cloth transactions involved credit arrangements that took months or even years to settle completely. The human side of this industrial machine was just as complex as the technical processes. Spinners, predominantly women working in their homes, formed the largest part of the textile workforce. They worked on piecework rates that provided crucial income for families, while allowing them to care for children and manage households. A skilled spinner could earn enough to significantly improve her family's living standard, making textile work one of the few medieval occupations that offered women genuine economic independence. Weavers occupied the middle tier of the textile hierarchy, earning respectable wages but facing constant pressure to maintain quality and productivity. Guild membership provided protection and guaranteed work, but it also imposed strict rules about training, pricing, and competition. Master weavers could earn enough to own property and live comfortably, while apprentices worked for years, learning techniques that would determine their lifetime earning potential. Fullers, shearmen, and dyers represented the skilled specialists whose expertise made the difference between ordinary cloth and premium fabric. These craftsmen commanded higher wages because their knowledge was difficult to acquire and essential for producing marketable cloth. Master dyers, in particular, were treated almost like magicians because their color formulas were trade secrets that could make or break entire cloth operations. The profit margins throughout the system reveal why cloth became medieval Europe's economic engine. Raw wool might cost a few pence per pound, but finished broadcloth could sell for several shillings per yard, markups that would make modern retailers jealous. However, these profits had to be divided among dozens of specialists, each adding their expertise to the final product. The economic impact rippled through entire communities, supporting not just textile workers, but also the farmers, merchants, transporters, and service providers who depended on the cloth trade. Guild protection systems created medieval versions of labor unions that balanced worker rights with quality control. Guilds set wages, training standards, and working conditions, while also enforcing quality requirements that protected the reputation of their town's cloth production. This system encouraged innovation within limits, while preventing the kind of corner cutting that could destroy market confidence in local products. Innovation happened constantly but carefully within guild structures. New techniques for improving efficiency or quality were adopted when they proved their worth, but changes that threatened traditional employment or quality standards faced resistance. This balance between innovation and tradition helped medieval cloth production evolve steadily while maintaining the consistency that made European broadcloth famous throughout the known world. Looking back at this entire process, from sheep to sealed broadcloth, reveals an industrial system that was far more sophisticated than most people imagine. Medieval cloth production combined advanced technology, skilled craftsmanship, quality control, international finance, and complex logistics in ways that created the foundation for modern manufacturing. A single piece of broadcloth represented the coordinated efforts of dozens of specialists, using techniques that had been refined over generations. This wasn't just an industry, it was the economic engine that powered medieval Europe's transformation from a collection of isolated agricultural communities into a connected network of trading cities. The streams that powered fulling mills, the skills passed down through generations of textile workers, and the international markets that valued European cloth all combined to create wealth that built cathedrals, funded armies, and financed the exploration that would eventually reshape the entire world. The stamped broadcloth that emerged from this process was more than just fabric. It was a symbol of medieval ingenuity, craftsmanship, and economic sophistication that proved Europe could compete with any civilization in the world. From a sheep's back to a merchant's warehouse, through the hands of dozens of specialists, and across thousands of miles of trade routes, that piece of cloth carried with it the accumulated knowledge and skill of an entire civilization. No wonder it paid for cathedrals and fleets. It represented nothing less than the transformation of medieval Europe into an economic powerhouse that would dominate world trade for centuries to come.